Hello everybody. Today, I don't know why I did that. Today we are going to do dividing polynomials. Sorry if you hear a humming, that's the fridge. Dividing polynomials is very similar to factoring polynomials. It is all about factoring polynomials. So I don't want you to get discouraged. It is something where it's a great skill because it allows us to practice factoring polynomials, which you will need for quadratics next unit, and you'll need it for next year as well. So let's go ahead and get started. Dividing polynomials can be broken down into two steps, basically. Step one, factor the numerator and factor the denominator if they need to be factored. So basically, if you can pull out a GCF, if it's a binomial, do it. If it's a trinomial, see if you can pull out a GCF, try the magic X to see if you can factor it and get it into simplest terms. No, not simplest terms. Just try to get it as factored as possible. Okay, so you can get prime factors. That's what I'm thinking. All right. Then what will happen is basically one of the factors, so it could be a binomial, it could be a monomial, it could just be a number, will be in common on the top or bottom, top and bottom. Okay, they'll have something in common that you can just go ahead and cancel out. Okay, so let's go ahead and start with an example. So example one, we just need to divide this. And so we look at this. The denominator is actually prime because I can't factor anything out. There's no GCF in common. It's not a trinomial, so I can't use my magic X. So that's good to go. I don't have to touch it. My numerator, since it's a trinomial, I'm going to go ahead and try to factor it. It doesn't look like it has any GCF in common because they don't all have X terms, so I can't factor out an X. The only numbers are 2 and 15, and they don't have a common factor. So I'd have to look in to see if there's a magic X way of doing it. So I'm going to do that over here. The numerator, so I just pulled it off to the side because I don't want the whole thing when I work with it because that gets very messy and very confusing. So I'm going to pull it off to the side, factor it, and then, if I can, and then put it back into the fraction, okay? So we already said this did not have a GCF, so we're going to go into our magic X. Remember, I'm trying to multiply up to something on the top, so the A and the C, so that would be negative 30, and I'm going to add to the middle term, which is actually a 1, okay? Remember, this magic X only deals with numbers, no variables. So I need something that multiplies up to negative 30, but adds up to 1. So again, this is the part where you really have to start thinking about it. Use your calculator, okay? Don't try to do this in your head because that's where it can get messy, all right? And you might actually find out you have the right numbers but the wrong signs, and then it gets all messed up, okay? So go through what multiplies up to negative 30. Well, 2 and 15 work, but they don't add up to 1. 3 and 10 don't add up to 1. Like negative 3 or negative 10, whichever one you put the negative with, doesn't work. 6 and 5. If one of them is negative, it will multiply up to negative 30, and if one of them is negative, it will add up to 1. So you just need to figure out which one should be negative. If I have a negative 6 and a positive 5, it adds up to negative 30, or multiplies up to negative 30, but it adds up to negative 1. So I switch the signs around. Negative 5 and positive 6 will add up to a positive 1. So now I got these two numbers, I'm going to replace the middle term with it. So it becomes 2x squared plus 6x minus 5x minus 15. So I go ahead and group it off. Okay, that negative in front of the 5 stays with the 5. Okay, so in this first one, they both have an x in common, so I can pull that out. And 2 and 6, their greatest common factor would be 2. So I pull out a 2x from that one. This one, because this first term is a negative 5, I'm going to try to pull out a negative number. So negative 5 and negative 15 both have negative 5 as a factor. So I pull that out. They don't have an x in common, so it's just negative 5. So I pull out 2x from this one and a negative 5 from here, and then make sure I divide it so I can get my leftovers. They end up having the same leftovers of x plus 3. So that's one of my binomials, and the stuff that I pulled out is my other binomial. So 2x minus 5 and x plus 3. Okay? So now I'm going to replace this, the two binomials, with the trinomial on the top. So I have 2x minus 5 times x plus 3 over x plus 3. Do you see how they have the same binomial in common? And because it's being multiplied, I can cancel it out, maybe. There we go. I can cancel those two out, which means I'm just left with the 2x minus 5. And that is my division, like answer. That's my answer. That's what I get when I divide them. Okay? Let's try another one. Okay, this one's a little bit more intense. So it's a lot more work, but we can do it. Alright, so we look at the denominator. They have stuff in common. Okay? They do have a GCF. And what they have in common, they have the -2. They both can be divided by -2. They both have at least two v's to give. So that's what I'm going to pull out. The -2 and the v squared. And then I'm just going to write the leftovers. So v minus 7. And that's how I'm going to write my denominator. The numerator is also very large and complicated. So I start off with the GCF. Do they have stuff in common? Yeah, at the very least, they all have at least two v's to give. Okay, and if we look closer, this -4, 36, and -56, they all have a greatest common factor of -4. So I can pull that out as well. So I pull out a -4v squared, and then I write the leftovers. I get v squared minus 9v plus 14. So with the trinomial part, I go ahead and make my magic x. I need something that multiplies up to the 1 times 14, which is 14. But I also need something that adds up to -9. Well, 2 and 7 will multiply to 14, but it will only add up to +9. So if I change the signs to -2 and -7, it'll work. So I rewrite it, and I don't lose the stuff, the GCF that I pulled out. That's still part of this. I go ahead and group it off. Okay, this first one, they have a v in common, so I can pull that out. The second one, they have a -7 in common, so I can pull that out. So the leftovers end up being the same, and the stuff that I pulled out becomes a binomial. So that's the simplified, or that's the factored form of our numerator. So I rewrite it with the factored forms. If you look at it, they both have a v and a negative, like v minus 7 in common. They also have a v squared in common. And the -4, -2 can be simplified because I can go ahead and divide it and just leave me with 2. So what I have left is the 2 and the v minus 2. And that would be my simplest form. Okay? So, we got one more example. There's no try on your own on this one at all. So we're just going to do the last example together. So the last example is find the quotient of this, which means it's the same thing. We're dividing, because quotient means to divide. Just remember, whatever's written first goes in the numerator, whatever's written second goes in the denominator. So I look at the denominator, see if I can factor that. There's no GCF. Okay, so I look at it. You might recognize that it's a special case, which if you do, go for it and write it out like a special case. However, if you didn't, we just need a middle term here, so I go ahead and replace it with a 0y. I need something that multiplies up to -4, adds up to 0. Well, that would be 2 and -2. So I go ahead and replace it, group it. First one, they have a y in common, so I can pull that out. Second one, I can divide both of them by a -2. So I do that. The leftovers would be y plus 2 for both of them, which is great. That's what we want. It's going to be the same. So the stuff I pulled out becomes one binomial. The leftovers is the other binomial. Okay. The numerator, look for GCF. There isn't one. They're so close to being one, but not for all three. So now I go ahead and look at it. I need something that multiplies up to 4, but adds up to -4. Well, that would be -2 and -2. So I go ahead and replace the middle terms with those. And I get that. Group it off. I can pull out a y from the first one, and I can pull out a -2 from the second one. So I go ahead and do it. and just divide by what I pulled out. So I get y minus 2 as the leftovers for both. So that's one of my binomials. The other one is the y minus 2 that I pulled out. Okay? So, in factored form, this is what my fraction looks like. Now, if we look at it, they both have the y minus 2 in common. So those will cancel out, leaving with just y minus 2 over y plus 2. And that's my simplest form. Okay? That is my divided form. So, when I say simplest form, it means I did the operation. When I say factored form, it means I undid the operation. I actually went backwards and undid the multiplication when I factored it. So you'll see a lot of the time it says simplify, which means add, subtract, multiply, or divide them. If you see factor, it means you have to undo that, and you should be able to get something that looks like it's not done. It looks like the problem, not the answer. Okay? So be aware of that. So that is it for this video. We will go over any questions you have on it. I mean, this is not a huge thing on the test or the SOL, but it's very good to know. Honors, I will probably show you one extra thing just as the honors topic. It has to do with long division, so I'm really just going to show it to you, and that's really it, okay? But I'll show you that next class, and I'll answer any questions next class, okay? Bye!